So hello my dear students. So today we will be discussing chemical bonding. So this is one of the very important topic for your IIT JAM biotechnology. Okay, so I will be showing you a few questions how previous year how are the what are the questions or what concepts they are focusing from this chapter and how easy they are. So once if you got some clarity over that, so you can easily prepare these topics. See here, the very easy question here I have. See, finding the structures and matching them with respect to structure. Very easy question. So within some minutes, even you can solve these questions more easily within short time when you compare with your bio questions also. So that much easy these questions are. See here, all are things from finding the shapes, hybridization, and what type of bonds between NaCl. What is the type of bond present between Na and Cl in this NaCl molecule and for H2 molecule? Very easy questions these are. See, 23 questions, you don't even spend some 10 seconds also. You can easily tick it. Okay, so shapes again. See, these are the biotechnology questions from this chemical bonding chapter. Again, see shapes, they are focusing on shapes, hybridization of given molecules. So these are the few questions which I am going to discuss. First of all, I will cover the topics, the concepts related to these topics, these questions, and the next we will finish these questions also, we will solve these questions. The remaining topics or remaining questions or the remaining concepts of this chapter will be discussed in the next session. It means in the upcoming sessions. Okay, so just now, what are the things I am going to cover today? So I will be discussing what exactly chemical bond and its types, and the next basic approach towards how the molecules having their shapes. Okay, so what is this fundamental Kozel and Lewis dot structure or approach? The next Fajan's rules. The next I will be explaining this hybridization and Valence electron pair repulsion theory. The short form I am mentioning it as VSEPR theory. So if you are done with this, mostly the questions from this chapter will be done from only this particular session. Okay, so one more topic, molecular orbital theory will be there, that will be in the next session. Okay, so so let me discuss first what exactly chemical bond. So it is something like force of attraction which is holding atoms or molecules together. That is the simplest way you can understand. Okay, so now why these molecules will form or why this bond formation takes place? This is the second basic question everyone will get. Okay, so why it will be taking place? To attain stability. So everything in the universe happens to gain stability right now. So this chemical bond formation is also taking place to attain stability. Okay, so now during this chemical bond formation there are different ways. So one atom may release electrons, I can say that atom may lose electrons and some other atoms require that electron. Okay, so the bond formation can take place by losing of electron and other one is by gaining of electron. So now we have resulting ions. Now when atom loses electron, it forms cation. When atom gain electron, forms anion. So now between this cation and this anion there is force of attractions. Right now opposite charges means force of attraction will be there. So that results to form one type of bonding. That is what? Ionic bonding. Between two ions we have ionic bonding. So we can say simply it is an electrostatic force of attraction. Okay, this is what? Ionic bonding. Okay, and then next there are few atoms both of them have one or two electrons less. By sharing the electrons they are mutually sharing. So this requires few certain amount of electrons and other one also. So they will share each other and they will become stable electronic configuration and they will attain stability. So I can say one is transfer of electrons, by transfer of electron, other one is by mutual sharing of electrons and other one is donation of pi electrons. I will show you this. Okay, so these are the basic ways that molecule can form atoms can form a chemical bond. Okay, hope it is clear up to here. Okay, so what is the fundamental reason? To attain stability. How this stability is attained for the elements generally? See, bond formation is associated with the stability. An element has tendency to occupy inert gas configuration which is considered to be stable. Now if a species, if an element in its ionic state or in its neutral atomic state having inert gas configuration is considered to be stable. Okay, if it is not, then they will try to attain this inert gas configuration by gaining or by losing the electron. Okay, so based on this, for example, we have this many types of bonds. First one is ionic bond, also called as electrovalent. Next covalent bond, next coordinate covalent bond, metallic bond, hydrogen bond and van der Waals. See here, in these cases, hydrogen bond and van der Waals bond, like there is no electron shifting and all. So this is simply like little force of attractions. Okay, so now what you need to know, especially you need to know about this covalent bond. For example, here we have sodium chloride, ionic compound we are saying. So here we know sodium is first group element, alkali metal. Okay, so what is its electronic configuration? So now we know its atomic number is 11. Okay, so I can write, see 11 means 10th element is what? Neon, right now. So neon is inert gas. Neon is inert gas. So it has 10 electrons. Sodium 11 means along with this 3s1. Now by losing this 1 electron from the sodium, it will become inert gas configuration. So that's why sodium is having high tendency to give the electron, lose the electron. So by losing this electron, it becomes Na plus ion. What about chlorine? Atomic number is 17. So we can write it as, what is the 18th element we have? Argon. Okay, if we got 18 electron, it has 17. By taking one more electron, it becomes inert gas configuration. That's why chlorine has tendency to accept the electron. This has donating capacity, that is having accepting character. Therefore, these donated electrons are taken by chlorine. Okay, that electron is taken by chlorine and it becomes chloride ion. So now both are oppositely charged species now. So they have electrostatic force of attraction and results to form a NaCl crystal. Okay, so ionic compound you can understand like this. Now ionic compounds are more readily soluble in polar solvents. What I am saying? So what is the example for polar solvents? Like water. What is a polar solvent we are saying? So ionic compounds are readily soluble, are easily soluble in the water medium, aqueous medium I can say. Okay, so whereas covalent compounds soluble in non-polar solvents and less soluble in polar solvent. Like this also you can remember. Okay, next, what about covalent bond? It is formed by mutual sharing of electrons. What is this mutual sharing? See, for example, I am taking so I am taking chlorine atoms. Okay, so 2 chlorine atoms. How many electrons are there here? 17 and 17. Okay, so now how many electrons in the valency? If I want to write electronic configuration, I can write, so 1s2, 2s2, 2p, 6, 3s2, 3p, 5. See, 10 over 12 plus 5, 17, done. So if we give one more electron, it becomes 3p6 electronic configuration, that is for argon configuration. Therefore, see, during the chemical reactions, just remember, only these valence electrons will take part. How many valence electrons are there with halogen? 7. So write them. Now itself I am giving you Lewis dot structure of this chlorine. So now what is the Lewis dot structure? See, each electron is represented with 1 dot. Okay, so 1, 2, 3, 4, 5, 6, 7. 7 valence electrons, 7 dots. Hope it is clear up to here. Similarly, this side also 1, 2, 3, 4, 5, 6, 7 electrons. Now each of them have 1 electron required now to gain noble gas configuration. Therefore, the electrons are shared mutually by both of them. Okay, so now what it becomes? So chlorine, like this, like this. Okay, so now count the number of electrons around each of this chlorine. 6 electrons, 6 dots, 6 electrons, 7th dot and 8th dot. So this shared pair electron belongs to both of them. Okay, so 8 electrons here and 8 electrons here, both are satisfied now, are becoming stable. So that's why chlorine will not exist like this. It will be in the diatomic state like this, Cl2. Okay, similarly oxygen. What about oxygen? See, we are saying oxygen, it's not oxygen atom. Oxygen exists in what? O2 form, diatomic form now. So here it will be something like this. Like this. So what you are seeing here, see 4 electron, 4 dots, 5, 6, 7, 8 dots are there for each of the oxygen, both are becoming stable now, right now. So like this. Okay, next coordinate covalent bond. What is this coordinate covalent bond? See, only one species will donate the set of electrons, like pair of electrons. For example, here I have BCl3. How many electrons are there around the boron?
5, 2, 3.
3 electrons are there. See, for more understanding, just hold for a few more minutes. We will discuss in the Lewis dot structure. Anyways, for example, I have a species. I am saying it as L. So this atom itself generate pairs electrons for bond formation with other atoms. For example, I have L and M. Things are there. So in order to make a bond, they are required 2 electrons in each bond. Right now, that 2 electrons are contributed by only one species. See, L is itself donating pair of electrons for bond formation with M. Okay, so it means M has some empty orbital. To that empty orbital, L is donating the lone pair electrons. So I can call this type of bond resulting like this is considered as dative bond or coordinate covalent bond. Okay, it is a special type of covalent bond. Simple covalent bond means mutual sharing, but coordinate covalent bond means only one species will donate pair of electrons for bond formation. Hope it is clear up to here. Yes. Okay, and then next this metallic bond, that is like present in metals, like how metal like sheet if you consider. So how it will be, like metal atoms will be there now. So between these metal atoms we have that metallic bonding. Okay, next hydrogen bonding, it's a special type of bond, we will discuss later. Okay, now basic understanding about the structures is given by Lewis dot structure. So what he considered, see Lewis considered the, if you write any electronic configuration for any of the atom, for carbon if I write, what is the electronic configuration you are writing? Atomic number 6, you are writing 1s2, 2s2, 2p2. 6 electrons are done now. So now during the bond formation, see in the formation of a molecule, only outer shell electrons take part in chemical bond combination. It means only outer shell. What is the outer shell? See, if this is a nucleus, this is the nucleus, I am writing yellow color as the shells. This is n equals to 1, n equals to 2. So what is our outer shell here? See, second shell is outer, n value 2 is outer shell. Okay, so n value 2 is belongs to these two things. So both of them are outer shell orbitals, right now. So these electrons, how many electrons are there? 4. Those 4 electrons will take part in the bond formation. Hope it is clear up to here. Now how can I represent that? See, either you can represent in the box format like this, okay. So now these valence electrons has to be indicated with the dots, okay. So only valence electrons, 4 are there now, carbon, so 1 dot, second, third, 4 dots like this, okay. Now tell me for boron, how can I write? Atomic number 5 means 1s2, 2s2, 2p1. So these 3 electrons are there now, so 3 dots like this. See, these are the representation of the Lewis dot structure of different atoms. Now by using Lewis dot structure, I want to show you the methane molecule. How can I represent this? Carbon has 4 valence electrons, 4 dots, 4. Okay. Now hydrogen has atomic number 1, so 1s1 electronic configuration. So each hydrogen has 1 electron. So 4 hydrogens, methane means 4 dots for each hydrogen 1 1. Okay. So now they will mutually shade like this, here and here. So we got a molecule now, methane molecule like this. Now count the number of electrons around the carbon. See, each bond, 4 bonds are there, each bond contains 2, 4 to the 8 electrons are there. So now carbon got noble gas configuration, okay, or this configuration also called as this 8 electron system is there now, that is also called as octet rule. What is that? Octet rule. The species which has octet rule configuration are considered to be stable. Okay, now methane is considered to be stable. Now you should get one doubt, like what about hydrogen, sir? Hydrogen contains how many electrons? One electron, but in the molecule it has two electrons. Now here you should not consider it as octet, you should say it as duplet. What is that? Duplet in case of hydrogen. In other cases octet. In case of hydrogen it should be duplet, it means 2 electron configuration. Our species having these configurations are stable. Okay, so he told that Lewis dot structure, after giving this, those molecules are stable which contains octet configuration. Now methane contains octet configuration, so it is stable. Now there are some limitations. Now you should expect what are the limitations, tell me. See, there are some compounds. For example, I am writing CH4, BF3 and PCl5. If I want to compare these three things, just now I have shown you methane is having octet configuration, something like this. But if you consider BF3, now tell me for boron, 3 dots now, like 2s2, 2p1. So write boron with 3 dots. After this, tell me fluorine contains how many? 9 electrons, but valency how many? So 2s2, 2p5. So how many electrons are required for each boron?
3 electrons.
1, see 2p5, 7 are there. In order to become 8, how many electrons become? 1. Right now? So each fluorine required 1 electron. So I am writing here fluorine. So valency electrons are 7 now. 1, 2, 3, 4, 5, 6, 7. Again 1, 2, 3, 4, 5, 6, 7. Here also 1, 2, 3, 4, 5, 6, 7. Right now? So now look, they are sharing their pair of like these non-bonding electrons becoming bonds. Now around fluorine you count, each fluorine contains how many electrons? 8 electrons. Now fluorines are happy, satisfied right now. But what about boron, center boron? How many electrons are there? 1, 2, 3, 4, 5, 6. Only 6 electrons are there. But for fluorines we have 8 electrons, this is happy now. But what about boron? How many electrons are there? No, in the molecule. Only 6 electrons are there. But what we know? Those species contains octet configuration are stable. But is this molecule contain octet configuration for the center atom? No. So it is only having 6 electrons. It means as per his statement that only octet configuration compounds are stable. It means BF3 should not be stable, it should not exist also. But it is being like formed or being existing. So it means this is a limitation of Lewis dot structure. Similarly, so now what I can say, if 8 electrons are there, I should say it is octet, stable, and here 6 electrons are there. If the electrons are lesser than octet, lesser than 8, we should say it is incomplete octet. So I can say this is incomplete octet. So question will be like this, you can expect which are the following are not following octet rule configuration or octet rule. Which are the following molecules are not following or not obeying octet rule. So you should answer based on this. So our BF3 is not obeying octet rule. Now what about PCl5? Phosphorus center atom right now. How many valence electrons with phosphorus? 15th group now. So 15th means 10 plus 5. So 5 electrons are valency. Okay, put that 5 electrons around the phosphorus like this. Okay, like this. Okay, after that chlorine required what? 17 means something like this, 7 electrons only. Each carbon chlorine required 1 electron. So I am writing chlorine over here, here, here. One is here, other one is here like this. Okay, so all of them have like this. See, they can make one bond like this, right now. Now count number of electrons around each chlorine atom.
Each chlorine atom will have
each chlorine atom is happy with 8 electrons. Octet configuration is obtained for all the chlorine atoms, all the 5. But what about center phosphorus atom? It becoming 10 electrons. See, 5 bonds are there, 5 to the 10 electrons it is. Now we know only octet rule configuration is stable, but here it is 6, it is 10, but it is also like existing. So now this is also limitation now. So there are some compounds which are having lesser than octet or greater than octet. They are also being existing. It means these are the limitations of octet rule, Lewis dot structure. Okay, Lewis dot explanation. So now here I should say this as expanded. See, this is incomplete, this is expanded, greater than the octet now, greater than 8 now, so I should call it as, see, number is something 10 electrons means 8 plus 2, expanded only now, expanded octet. They will ask a question, which are the following contains incomplete octet, or which are the following molecule contain octet rule configuration, or which are the following contain expanded octet. Based on the structures, like writing their Lewis dot structure, you should answer those questions. Okay, hope it is clear. Now one more, the limitation of this Lewis dot structure is he doesn't explain exact structure of the molecule. For example, you are writing methane like this, but if you see originally methane will not be like this. What is the structure of methane? Tetrahedral, right now, but if you see here something like a square or something like that. So there is no proper explanation about the structure in the Lewis dot structure. Okay, he just given basic dot symbol, that's it. Okay, hope this is also clear. Two main limitations. Okay, so done with this. Yeah, so just read this. Incomplete octet of central atom, these are the limitations. Yeah. Honey, who is in chat box, so just go back for a few minutes, just rewatch it so that it will be clear. See, BF3 I told now, for all the fluorine atom it is becoming completely filled octet configuration, so for all these fluorines, but whereas for boron, see, only 6 electrons are there, that's why I am calling it as incomplete octet, but we know if 8 electrons are there, it is considered to be stable by following octet rule configuration. Since it has 6 electrons, I am writing it as incomplete octet and not obeying octet rule. Next. See, one more thing. See, xenon belongs to which group? It is a noble gas. It means it has 8 valence electrons like this around it. But what he told that the species containing 8 octet rule configuration is stable, they won't show chemical reactions. But see, xenon is having octet configuration, but it is exhibiting some chemical reactions, or it is forming some compound becoming from octet to some expanded octet by gaining or by forming some chemical compounds. See, still forms some compounds. It means 8 electrons are there. It means it should not show any chemical reaction, but it is showing. So that is also a limitation. Okay, got it, I think. Okay, next. So tell me answer for this question. Which are the following expanded octet? Only PCl5? Check it. Nothing to check, man. See, what is the center atom? Carbon. So carbon has valence electrons 4. We know for each chlorine we have 7 electrons, one electron each side. Right now, so it is expanded, not expanded, it is perfectly octet. Okay, it is octet, this is duplet, this is incomplete octet. Okay, this is expanded octet with 10 electrons. This is 2 electrons, you should say duplet. This is 6 electrons, incomplete octet. This is octet. Okay, so our option will be expanded, means option 2. Right, next. Ionic compound, how it will be formed? By complete transfer of electrons from one atom to another atom, like sodium chloride we have seen. Okay, so these are the 3 factors deciding or influencing the formation of ionic compound. What are those? Ionization energy for cation, electron affinity of anion, and when they combine we will get some energy called lattice energy. These are the 3 factors decides. Okay, see sodium like that will be donate this electron to here, okay, it becomes NaCl by transfer. See, complete 2 electron comes from here to this outer shell of chlorine. Next, so these are the extra points that will be needed for ionic compounds. So these are hard, brittle, and next they are crystalline, have high melting and boiling points. They are polar in nature, so therefore they are soluble in polar solvents. Okay, so linkage between oppositely charged ions is not rigid and non-directional. Okay, and they are soluble in polar solvents such as water and insoluble in non-polar solvents like CCl4, benzene and all. Okay, and these are good conductor of electricity in their molten state and in their aqueous state. See, fused state or molten state I can say, and in the solution state. So what is the reason for their ionic conductance? What is the reason for their conductance? Because of presence of ions. Like see, mobile ions are there, na, mobility of ions like Na plus ion, Cl minus ions, easily mobile, they will carry the charge, carry the electricity. Now whereas in metallic conductors means metals are there now. What is the reason for metallic conductance? You should say there is due to mobility of electrons. Like free electrons are there, so that free electrons or mobile electrons are the responsible in case of metallic conductance. But in these compounds, for ionic compounds, ions, that's it. Next, this is also done. So how the bond formation takes place? Sharing. Okay. Active transitor. Now ionic compounds we have studied now. So now specifically we are studying covalent character in ionic compounds. So what does it mean? Covalent character in ionic compounds. See, I can say we have ionic compounds like just now we discussed about NaCl, right now, like CSCl, cesium chloride, all these are what? Ionic compounds. But there is no 100% ionic compound. It means there exists at least some amount of covalent character in that given compound. See, I am saying these are ionic compounds, but not 100%. There is no compound which is perfectly, completely ionic. There means there exists some covalent character in that compounds. Now both are ionic compounds now. I just want to compare which is having more covalent character or which is having more ionic character. So that will be answered using this explanation. So what is the heading here? Covalent character in ionic compounds. Okay, this is explained using Fajan's rules. Okay, I will explain now what exactly Fajan's rules. See, just understand this. This is something like, see, in a cation, anion is there. Even though they have cation, anion, we know this electron cloud is expanded, like more negative charge means more electron density. This is positive charge means more positive, like positive charge means what it will do? It will drag the electrons from here to this side now. It means, see, there is something like mutual sharing here, something like you can understand this. Okay, so for more clarity I will explain, wait for some time. Okay, so note, what is the note point? There is no compound which is 100% ionic. There is, in every compound there is some covalent character. Okay, that will be explained by Fajan's rule. So what are these Fajan's rule? Very easy, just hold on for some time, you will get clarity over this topic. Very easy. See, if I have smaller cation size should be small, I am saying. So if small size cation, it means that positive charge, see, size is small. Now effective nuclear charge will be more now, it will more effectively attracts the negative charge particles around it. For example, small size cation I have and large size anion I have. So now what happens? See, large size anion, it means it also has some nucleus, but electron cloud is expanded for this. Now this one is having more positive charge and this is having more negative charge. Now what it will do? It will drag this electron cloud towards itself now. And now what happens? That electron cloud is shared between these two ions, like two nucleus. So I can say that is generating more covalent character now. So what is the first condition? Cation should has smaller size, okay, and it can have more positive charge. See, smaller size, more positive, both says same thing only. See, more positive charges also attract electron cloud very effectively towards itself. So that creates more sharing, mutual sharing. Yes or no? See, these 2 points are there now. So these are called polarizing power of cation. More the polarizing power of cation, more is the covalent character for that particular ionic compound. Is that clear? Next, anion conditions are large size anion. Anion should be how? Should be large size. It means electron cloud should be expanded. That will be easily taken towards the positive charge. Okay. So next, more negative charge. See, more large anion I can say, or more negative charge. More negative charge is means what? Electron cloud is expanded. Right now, that is what you need to understand. Next, cation with pseudo inert gas configuration has more polarizing power than the inert gas. For example, I have sodium plus, I have copper plus. Both of them have same positive charge, +1 okay. So now, but you know what is the atomic number of copper? 29, right now. So how do you fill the electrons? Argon 4s1 3d10. So argon means you are getting 18 electrons. For sodium you are writing neon, so 10 electrons. So those species having this 18 electrons are considered as pseudo inert gas configuration. Now pseudo inert gas configuration containing like cations having more effectiveness for dragging the electrons when we compare with the normal inert gas configuration. So polarizing power of cation with pseudo inert gas configuration is more than this. Okay. So now if I want to compare NaCl and CuCl, so now tell me, anions are same here. I cannot decide my answer with respect to anion. Now we have only option with cation. So Na plus Cu plus. Now tell me which is having more polarizing power. Cu plus is having more polarizing power due to its pseudo inert gas configuration. So this will drag the negative charge or the electron cloud from anion, chloride ion more effectively. Therefore that creates more covalent nature. So from NaCl and CuCl, which is having more covalent nature? CuCl. That's it. Like CuCl, covalent nature of CuCl is greater than NaCl. Are they asked for ionic nature? Reverse. Then CuCl. Clear now? This is clear. Now, what is the application of studying this thing? Now, out of this CuCl and NaCl, which is more soluble in water?
More soluble in water is ionic.
More ionic one will soluble more easily in the water. So, NaCl readily soluble when we compare with the this is what you need to understand. As covalent nature increases, solubility decreases in the polar solvents. I hope this statement is also clear. Okay. Next, here these 5 points are very, very important. Now I will be asking you a few questions. So tell me, I have NaCl and KCl. So tell me, out of these two, which is more covalent and
Covalent is KCl.
how you are saying more covalent
Because
is?
it has a pseudo electron.
This thing is there now. This is applicable only in case of transition elements like pseudo inert gas configuration, you compare there. Okay. So now here we have Na plus Cl minus, here K plus Cl. Now compare Cl, we can't give our answer with respect to anion. We can give our answer with respect to cation. But out of these two cations, what I told you, cation size should be smaller. Which size is smaller here out of the? We know size we discussed now in a periodicity. Na plus, Na, K plus. So which is smaller size? Rubidium plus.
As you go down the group,
Size increases. So smaller is.
Na plus.
So effective nuclear charge will be Na plus will be more, polarizing power of Na plus is more. Therefore, which is more covalent here? So covalent nature will be NaCl greater than KCl. Right now? Ionic means opposite, like that. Okay. So now we will be showing you few more questions. For this you tell me, these are alkaline earth metals. See, chloride, chloride, chloride. We can't answer with respect to anion. We have only option with cation. So cation here it is Ba plus 2, Cr plus 2, Kc like this. So now tell me which is having more size or less size?
The less size is beryllium
Beryllium size is smaller. Therefore, small cation
and larger.
anion have more polarizing power for cation here. So that makes it to be more covalent. So which is more covalent here?
Beryllium.
Beryllium. After that magnesium like this. This is the order. Okay. This is the order. Okay. So what is the like important applications here we have? See, melting point decreases with increase in
Covalent character.
it means this is having more covalent character. This side is more covalent right now. So this side is ionic. So melting point decreases with increase in like this. Next, solubility decreases with increase in covalent character. Okay, in polar solvents. Okay, and moving from BaCl to B's covalent character increases. Oh, covalent character increases. That's it, na? Increasing only. Next. So, and moving from calcium fluoride to calcium iodide. You tell me this.
Calcium fluoride.
Which is more ionic, which is more covalent like that? CaF2, CaCl2, CaBr2 like that.
Because iodine has bigger size. We can call that
CaI2. So which is having larger size here? All our calcium ions are same. Now our answer should be with respect to anions. So smaller here, larger here. Large anion, more polarizability, so more covalent nature. For anions, size should be larger. For anions, charge also should be larger. Okay, for cations, size should be smaller and charge should be bigger, like +3, +4 like this. More positive charge, more effective nuclear charge, more polarizing power. So therefore, which is having more covalent nature? Like this. Based on this, see, and moving from F2 to I2, melting point decreases. Why decreases? Covalent nature is increasing. Covalent nature increases, melting point decreases because ionic compounds have more melting point. That's it. Next. Now tell me for this, whether the statements are correct or not.
FeCl is more covalent than FeCl3.
FeCl2 is more covalent than FeCl3. Whether the statement is correct or not. Easy. Write the structures now. Cl3. What is the cation here? Charge plus 2. 2 chloride ions. Each one is ion, chloride ion. Here it is Fe3 plus chloride ion. So anions are same. Our answer should be with respect to cations. Where more positive charge? So polarizing power will be more for. So more covalent character will be for. That's it. That's it. This is the correct order. They are saying is more covalent than this one. So it is incorrect. Second statement.
FeCl3 is more covalent than
That is correct. Third one.
covalent, not equally covalent.
So option
2.
perfect answer. Right now. Next. Now I am also asking this basic question because very basic question is there like this in the exam. Just answer this. Which are the following contain both ionic and covalent bond? Try to write the structure. So tell me, NaOH. So NaOH means we know sodium, alkali metals always in positive charge in their combined form, +1. Okay, now OH minus. Okay, so now if we look it like this, it has ionic nature. Okay, what about this O and H? They have one bond between each of them, O and H. So what is this bond? Covalent. So it contains both ionic as well as now tell me for second option. So that is ionic bond. See, see Na, how many Nas are there? 2 Nas, 2 Na plus. So sulfate minus. So these are ionic now. Now between sulfur and oxygen, covalent bonds are there. So sulfur, like I can write like this. Here one sodium, here one sodium ion, like this. So these are what now? Covalent. These are ionic between Na and Cl. Okay, this is both are having both covalent and ionic. What about KCN?
K is positive.
K is positive.
And
C N minus it is. Okay, cyanide. See, cyanide, nitrogen, carbon and nitrogen, carbon and nitrogen. Between them,
carbon and nitrogen, carbon 6 and
so between them we have covalent bonds. So between them it is covalent, between these two ions ionic. So all of these have both ionic and covalent. And next I am adding one more option. I am writing KCl. It has only K plus Cl minus. So we can say it is just ionic, not covalent. Okay. So your answer should be first 3, it means fourth. Okay, clear now? Yes, now I am writing what about this? Ammonium sulfate. Just write ammonium sulfate I am saying. So what are the cations here we have? NH4 2 NH4 plus ions. And minus. So between nitrogen and hydrogen there will be covalent, between oxygen and sulfur covalent, between these two ions ionic. It has both. Very basic only, but try to understand like what we are doing. Again, so how I am splitting these two, how I am inserting the charges. See here, see if I am writing AB, this position, A position is for cations, B position is for anion. Always first write cation, then write anion. Now I am writing something like this, AB, I am writing X here, Y here. Okay, so when I am splitting these, I will be bringing the number mentioned for B will be given here as a charge for cation. So I should write A plus. How many A's are there? X number of A's. So X A to the power Y. And how many B's are there? Y. Number of B's. X. What is the charge I should represent? Minus. Like this. Now tell me for this, apply same concept and tell me. 2 NH4. What is the charge? What is the number here mentioned? 1. Sulfate ion together it is 1. So 1. That's why plus 1. For sulfate ions, 1 sulfate ion is there having charge of this 2 right here. Crisscross method we can call. Okay, next. What about this?
The greater covalent character of anion found if small size of cation, large size of small size of anion, only one cell.
Greater covalent character of an ionic compound. If small size cation,
large size of anion, it should be anion.
Large size anion, but they are mentioning small size anion, larger size cation. No, only option A is perfect. Okay, yeah, true. Okay, next. Only one option number 1 we can go with. And next, let me show. Look at this, very easy, just try this question. With whatever known concepts you have, just give it a try.
NaCl is ionic bond.
Ionic bond, okay. So they are saying type of bond present between them. So NaCl
Ionic bond.
matched. Next,
Carbon chlorine is
this one.
covalent bond. It should be covalent.
H one electron, another H also one electron, mutually shares to form a duplet configuration, H2, like helium electronic configuration. So it is covalent. So Q3, okay. Next, now based on this, just look what are the options we have. P4, P4, this eliminate, P4. Next Q3, 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 okay, eliminate this one, okay. Now what you have only between 2 and 4. So now between carbon and chlorine, bond is what type of bond it is?
Carbon and chlorine.
Is it carbon chlorine? Chlorine required 1 electron,
Yes,
carbon required like 4 more electrons, so it can form 4 bonds. We have seen tetrahedral geometry. So that is covalent bond, but we know there is electronegativity difference between carbon and chlorine. Which is more electronegative?
chlorine is more.
So that makes partial positive charge on carbon and partial negative charge on chlorine. So I can say this is covalent bond, but it is polar bond, whereas this is covalent bond but electronegativity difference is 0. Both of them have same electronegativity. So this is covalent bond but it is non-polar. This is covalent bond and polar. So covalent bond polar. So S2, only this option, okay. And what about 3? Like R1, see palladium and phosphorus bond in PDPPH3. See, these are called coordination complexes, coordination compounds, okay. So in these we have metal atom like this, palladium. So metal atoms we know they have vacant d orbitals, like you are saying now. Now for manganese you tell me. Manganese, cobalt, all these things, what they will be having, like manganese atomic number 25. So I told you 3d5, 4s2. For this atomic number 27, I told one trick, 4s2, 3d7, something like this you should write. I told now. Now see, there are 5 d orbitals, in that only 7 electrons, here only 5 electrons. So few more space is there to accommodate the electrons, right now, okay. So to that, this any other atom is combined, that atom will be donating the electrons. For example, palladium here we have, so to that PPH3 is mentioned here, see, triphenyl phosphine, what is that? If it is PH3 you should say phosphine, okay. See, in the place of hydrogen we have phenyl groups. How many are there? 3. So I should call it as triphenyl phosphine, okay. So palladium, PH represent phenyl group. How many are there? 3. Phenyl is something like this, benzene ring is there, that one, okay. So now these will be donating electrons to palladium. See, I have indicated arrow mark from only from phenyl group to palladium. So 2 electrons are coming from where? Phenyl group only. So it means what type of bond I should call? Dative bond or coordinate covalent bond, okay. And here they are mentioned it as coordination bond. So in this coordination bond also, that is given from ligand to metal. Since this is metal, these are called ligands. Ligands donates pair of electrons to metal. Those bonds are called coordination bond. So that is R1, okay. So that's why option number 2 is perfect one. Hope it is clear now. Yeah. Next thing is we need to discuss about hybridization and structures. So what is this hybridization concept? See, hybridization is a theoretical concept to explain how molecules are existing or molecules are forming. Like for example, Lewis dot structure unable to explain what is the shape of this methane. By using this theoretical concept called hybridization, we can express what geometry it has. Like we are saying this methane is having now tetrahedral structure, and the next ammonia, what exactly it has, and what about water molecule. So these things, what is the shape or structure of this water and ammonia, we can explain using this theoretical concept called hybridization. Okay, so now who given this? This is given by Linus Pauling. Okay, so what he says, the atomic orbitals, see carbon has its atomic orbitals now. What are the atomic orbitals of carbon? 1s2, 2s2, 2p2. Okay, for hydrogen 1s1. So the atomic orbitals of these atoms combined and forms hybrid orbitals. What are these atomic orbitals first? What is the central atom out of these two? Carbon. So the atomic orbitals of this central atom, only valence atomic orbitals I am taking. They will mix together. It means why they will mix? For example, if I say s orbital, that should be like a spherical shape, and p orbital will be something like dumbbell shape. If I say px, py, pz, how they are? They are like 90 degrees to each other, something like this, right now. Now what they will do is they will intermix. What these atomic orbitals having their own independent energies, they will intermix to form hybrid orbitals. What is this hybrid orbitals? Now all those orbitals will have equal energies. So now how many p orbitals are there totally? P orbitals total. See subshell, if I ask, p subshell is 1, but in this 3 p orbitals are there, px, py, pz, and s orbital is 1. Okay, like this. If I represent in boxes, you might be remember. Like this. 1 electron here, 1 electron here. These are atomic orbitals. Now what I am saying? Hybrid orbitals. So these have different energies. This 2s is having different energy and 2p is having different energy. Like 2p is more energy than 2s. Okay. So now by intermixing these two, we will be getting hybrid orbital. Total how many orbitals are there? 1, 2, 3, 4. So 4 boxes you can write. Okay. After this, these are the 4 hybrid orbitals. I am saying they have equal energies. Okay, they are equivalent. So how many s orbitals here we have? 1. Now you should not say this is s orbital. Now you should call it as 1s 3p mixed now. So you should say them as sp3 hybrid orbitals. Okay, so how many s orbitals are there here? You should not say it is s, it is sp3. How many sp3 hybrid orbitals are there? 4 sp3 hybrid orbitals. This is sp3, this is also 4 sp3 hybrid orbitals are there. Now when they are with equal energies, give 1 electron to each of that orbitals. How many total electrons we have? 4. So give 1 here, other one like this, 4 given. Okay, this is about center atom. Surroundings are hydrogens. How many are there? 4, and each one with 1 electron. So the hydrogen atom having 1 electron, like 1s1 electron, that will be shared with this, and another hydrogen like that. How many are there? 4. Like this, 4. Like they will get paired up like this and form a molecule. Now check how many electrons of them are having? 8. So it is having octet configuration here also. Now one more thing you need to know is, if I compare atomic orbitals, they are having like perpendicular to each other. But when I say hybrid orbitals, they will redistribute their energies and become equal in all their energies. All orbitals will have same energies. Now the orbitals, these 4 orbitals are arranged in such a way that all of them have equal energies and equal repulsions between the orbitals. For example, see, if I write orbital here and here, they just have 90 degrees angle. Okay. Now I am redistributing their energies and writing the orbitals like sp3 hybrid orbitals, something like this. See here the shape, the angle between them will be 109.5 degrees if I rearrange them like this. So where we have maximum separation? Second case, hybrid orbitals case. So that's why they will be separated maximum, therefore the electronic repulsions will be minimum here. Here just 90 degrees they will be having electronic repulsions between these two, but here separated maximum means electrons are placed at maximum angle, so minimum repulsions, more stable. So which one is more stable here? Hybrid orbitals are more stable. That's why molecule is existing with tetrahedral geometry. Now see, this is a carbon atom hybrid orbitals, these are the hydrogen atoms like this. Now each of these hybrid orbital contain 2 electrons like this. These are what? Hydrogen, 1s orbital of hydrogen, these are sp3 orbitals of carbon. So single bond formed now, that is called sigma. So how many sigma sp3? 4 sigma bonds are formed here having sp3 hybridization. So with sp3 hybridization, what is the geometry? Tetrahedral, short form TD I am writing. What is the bond angle I told you? 109.5 degrees or 109 degrees 28 minutes. Okay, like this you can write. Okay, this is about methane hybridization. Now we need to know about ammonia and water. So that will be discussed in the next session. Okay, about the shapes we will discuss in the special session in the upcoming week.